Chapter number 16, Waves 1. 16, Margin 1, Transverse Waves. What is transverse waves? Learning objectives. After reading this module, you should be able to identify the three main types of waves, distinguish between transverse waves and longitudinal waves, give a displacement function for our transverse waves, determine amplitude Ym, angular wave number k, angular frequency omega, phase constant and direction of travel, and calculate the phase kx plus minus omega t plus phi and the displacement at any time and position. Give a displacement function for transverse waves. Calculate the time between the two given displacement. Sketch a graph of transverse waves as a function of position, identifying amplitude Ym, wavelength lambda, where the slope is greatest, where it is zero, and where the string elements have positive velocity, negative velocity, and as well as zero velocity. So, given a graph of displacement versus time for a transverse wave, determine amplitude Ym and a period t. Describe the effects on a transverse wave of a changing phase constant phi. Apply the relation between the wave speed v, the distance traveled by the wave, and the time required that in travel. Apply the relationship between wave speed v, angular frequency omega, angular wave number k, wavelength lambda, period t, and frequency f. Describe the Describe the motion of a string element as a transverse wave moves through its location, and identify when its transverse speed is zero and when it is maximum. Calculate the transverse velocity ut of a string element as the transverse wave moves through the location. Calculate the transverse acceleration at of a string element as the transverse wave moves through its location. Given a graph of displacement, transverse velocity or transverse acceleration, determine the phase constant phi.